Rivera. I'm very excited to bring our second lecture here about different glycolytic pathways and different ways that our body is able to use energy. For anybody who wasn't available, didn't see the first lecture, no worries. You'll still be able to follow this one. For anybody that did, thank you for checking out lecture number 2. So what we're talking about today is really the fate of lactate, the breakdown and metabolism of lactate, and when our body is able to use that as an energy source. So I just want to get started here by showing us an actual picture of what's going on. So as you'll see, there's 2 major steps to make sure that that lactate is used efficiently in the body. There's a portion that happens in the muscles called glycolysis. There's a portion that happens in the liver called gluconeogenesis. Now, from the beginning, we'll have glucose coming into the muscles. That gets metabolized and broken down, and it becomes pyruvate, the 3-carbon structure that we talked about in our last lecture. Pyruvate in the muscle is broken down to lactate, and when our body meets certain specifications as to energy requirements, it'll use that lactate to produce more glucose and produce more energy. But it can't do that in the muscle. As the muscle is contracting, it uses the amount of energy that it has. It converts that pyruvate into lactate. But for us to be able to get lactate to a usable form once again, we have to get it out of the muscle. So it's actually transported through the blood into down the pathway into the liver. Now, when it reaches the liver, it's kind of like what happens in glycolysis, but a little in reverse. And by this, I mean that lactate is then converted into pyruvate and then converted into glucose. And the process there is called gluconeogenesis. Now, a cool thing about that is that when lactate is converted into pyruvate and pyruvate goes to glucose, it's done through a process called lactate dehydrogenase. It's using an enzyme called lactate dehydrogenase. And the nice thing about that is not only creates our energy usable glucose, which will again transport through the blood and go right back into the muscles that need it, giving us an always productive energy cycle, but it's also producing an NAD or an NAD molecule. And this is what we're going to be using in further down the glycolytic pathways as an energy and electron acceptor in the electron transport chain. So just seeing what lactate can do in this small cycle really breaks down how energy is available for the body down the road in different types of pathways. Now, one might be thinking, when is it that our body's really going to be needing this? And what research shows is that when energy is more readily needed, so higher exercise intensities, there's going to be a conversion of lactate and the hope to get more NAD molecules in order to produce more energy down the road. I have a table here that some of you have seen before, and if this is new to you, no worries. But it really breaks down just when what's called fast glycolysis or here the lactate pathways are really necessary. And it's when intensities are high in our exercises and when they're very short in duration compared to something like running a marathon. Now here, what I want you guys to focus on is something like resistance training. Resistance training is going to be a perfect example of when we want to acquire lactate and get the most energy out as fast as possible. And that's really what we're looking for. Something that's going to require a high intensity and a short duration. So power exercises. We're lifting something very heavy and we need to push it very quickly. We're not going to be lifting a weight over our head for 3 hours. We want to push it up and get it into position and work out those muscles quickly. But we can't wait for a process like oxidative phosphorylation that's going to take a few minutes to work. We need something in the moment, and that's when fast glycolysis and these lactate pathways are really firing. So the more that we're doing resistance type training, the more that we're doing high intensity trainings, our body's going to favor these types of pathways in order to have a readily producible energy source. Now, one might be thinking, when I work out, I build up a lot of lactic acid, but that's not really the case. And it's lactate versus lactic acid. And I have both the molecules and structures here. And if you're really paying attention to it, there's not much of a difference other than that one hydrogen molecule. But we break it down just like any acid. An acid is going to be a molecule that's readily available and readily able to donate a hydrogen or a proton atom off of its structure. So lactate's actually going to be the conjugate base of lactic acid. And lactate's what's needed to go through the processes that we talked about before to be broken down at pyruvate to go through lactate dehydrogenase. So although lactic acid is available and it is building up when we're doing different movements and structures in the body, we need to get it readily out. And the way that we do that is through exercise, through muscle contractions, and through the conversion to lactate, because lactate is going to be what can go down the bloodstream and into the liver and can actually be turned back into the energy sources that we need. Lactic acid, although it's very similar in structure, isn't actually completely able to do that. It needs to be converted and needs to lose that hydrogen through a couple different reactions. So when can lactate be metabolized and used as an energy source? If we're really thinking about it, anaerobic is going to be the main word here. So we're in a situation where we have low energy and we need to produce energy for the body. I apologize, we're in low oxygen environments and we need to produce energy for the body. Situations where we are getting ourselves to a point of exhaustion. You feel your body breathing in, breathing out, breathing in, breathing out. We're trying to get more oxygen in, but we need those quick bursts of energy and that quick burst of readily available ATP. If we also need to do a fast regeneration of NAD molecules, this is going to be a perfect time for lactate to be the primary usage and the primary substrate that's being metabolized. Because it's a quicker process and because it allows us to really go back into what we're doing and get these quick actions done while not sacrificing different stores of energy or substrates in our body. So it gives us a way of producing quick and fast, powerful energy. Now, with the rise of lactate, one might be thinking, what is it that's happening in the body and what's causing fatigue? And although some scientists and some researchers want to say that the increase in lactate concentration is going to be the reason that we start feeling fatigue, there's actually research that shows it's not necessarily just a production of lactate. Lactate's actually available and it helps cleanse out the lactic acid that's in the body. So it's actually a benefit to have high lactate in the body. But what we're seeing is that when we exercise, we're going through our ATP stores. We're using the energy that's readily available through different processes in the muscles directly, because ATP is going to be our fuel source, and we want to use the ATP to produce the actions and the efficient workouts that we're looking for. But once we're running out of ATP, we're hydrolyzing in, we're getting a lot of inorganic phosphates. We're changing the pH that's available in the muscles. And when we're thinking about homeostasis, we really try to keep everything very common and very stable in a certain range. So if we're starting to increase a lot of bases or acids in that situation, we're going to have metabolic processes that can no longer go on at the same rate, which is one reason why we'd see a drop off in exercise and why we'd have to stop, why we start feeling fatigue. On top of that, with the breakdowns of lactate, we're getting that hydrogen that's now able to be donated and it's broken off. With a rise in hydrogen ions, we're again changing the pH, so we don't have that same homeostatic point to maintain all the energy functions and those energy metabolic processes that need to be happening. And if we're thinking back about the chart that I had earlier, we did talk about phosphocreatine is on as a system that happens initially. So that's going to be the first energy source for something that's very extremely high intensity, but very, very short in duration. So if we're running out of that energy source and now we're relying on lactate, eventually we're going to start running out of the substrates that we need in order to reproduce these processes over and over again. It's kind of like going to the bank. Eventually we draw money enough times that we're going to overdraw. We're going to have to slow down. We're not going to be able to get the money that we're looking for in the same way that our body's not going to be able to keep cashing those ATP checks over and over and over again. We will need to slow down and give our body a chance to regenerate all the energy sources that we have, the NADs, the ATPs, everything that's available to us. So that's just a quick overview of what we're going through and how lactate is a benefit and an energy source for the body. If you guys have any questions, feel free to reach out to me. Last slide is also going to be our references, a couple different exercises, and a great book. If you guys have anything and time to read it, I highly suggest it. Again, thank you for your time and